Hi there, in this video today I want to talk about the life cycle assessment of a product. If you like, what is the effect of a product on the environment during its lifespan? Or if you like, what's the effect of that product on the environment from the cradle to the grave? If you take any product, there's basically four steps involved. One, there's 2, 3, 4. These are extraction, and processing of the raw material. The extraction and the processing of the raw material. Then there's the manufacturing, the manufacture of it, and then how is it going to be used, the use of it, and finally the disposal, i.e. it's born, it lives, it dies. Let's look a bit more at the first, extraction and processing. These materials, everything is made from something that comes from the land, sea or air, but let's take some little examples. Iron, steel. Iron, it's Fe2O3. It's got to be taken out of the ground, and then it's going to be shipped to so-and-so to a blast furnace, and the blast furnace has got to be warmed up, and then the molten iron run off, etc, etc, etc. Another thing, aluminium, exactly the same again. It's an ore. It's got to be extracted by electrolytic means, and you know that is an expensive process. Then it's got to be made into aluminium in a form that can be fabricated and used. So the raw materials, mining, extraction, you can go on and on and on. So things don't just appear, they've got to be, if you like, mined, extracted from the earth or from sea or from the air. The next thing is the manufacture. If we took iron and steel again as our example, they've been extracted, then they got to be fabricated in factories, made into certain products, and that could involve making them into sheets and wires and cables and even plastics. You know, they've got to be blown in molds, injection molds into certain products. And the next thing is the disposal after them. But before I mention that, I mentioned the use. You take something like, let's say, a garden chair made out of wood, that it can be used as soon as it's been made. It's used and used and used for years and years and years until eventually it rots and it's got to be thrown away, it's got to be disposed of. Whereas a plastic chair, for example, maybe it's going to last 100 years. And it's a bit like people's brains. If they're not used at all, they last a lot longer. Anyway, that's beside the point. And the final thing is the disposal. Once something is dead, it's gone to the grave, a product, what do you do with it? It can't just be left about, because you have to dispose of it. And all of those four things manufacturing, fabrication, extraction, use is in quotes, and the disposal requires transport, shifting from A to B, and if it's a complex project or product that you're making, it could involve 50 different steps, which all involve transport. You know, like you take something like rubber on your shoes or on your sandals, all the way to the rubber plants, then it's got to be cut down, then moved from A to B, where it's then the rubber is extracted, then it's got to be put into whatever it is, then put on the ship or put on a cargo carrier or on a flight, then shipped from A to B to C to D to E, and there's a cost involved with that. Now, let's get back to what I really wanted to talk to. It's the life cycle assessment. Assessment, judging, calculate. How would you judge or calculate the cost of the effects of a product on the environment? It's difficult because there's lots of guesswork, and manufacturers, I shouldn't say this, maybe they always look on the bright side of life and they say things like it's green friendly, it's biodegradable, etc, etc, etc. What they do is they cook the books so that everybody thinks that their product is wonderful. So let's look at the steps involved in a typical LCA. After that, I'll give you an example. 2, 3, 4, 5, 6. How much energy? How much energy is used or required to make that project? Then after that, we've got amount of resources used, how much waste, how much water, how much greenhouse gases. I'm just going to put gases there, and finally, what have I missed? I'm just looking at my thing. How much resources, energy, that will do for the time being. How much energy, I could put in fossil fuels, etc. Anyway, I want to look at an actual example. Now, this would be the life cycle assessment to make a bag. Supermarket bags, cardboard and plastic, polythene, polyethylene. Let's look at this chart. Okay. You see, I haven't practiced this, but this is going to be the step or the stage in the LCA, the life cycle assessment. This is the stage or step, and this is the figure for paper, and this is for the plastic bag, polythene, polyethylene, for example, plastic. Just going to fill this in now. The energy needed, the energy, fossil fuel, how much coal, how much oil is used, the waste, greenhouse gases, and finally how much water. I fill these figures in. I've got a very good memory. That is 2590 kilojoules, that's 28, that's 34, that's 72, and that is 3387. And this is 713, that is 13, that is 6, that is 36, and that is 198. I'm just going to put an extra column in there so we know what the units are. Megajoules, that's a million joules. Kilograms, 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 and finally litres. Let's look at that. What's the more eco-friendly product? Is it these figures are about approximately for a production of 1,000 shopping bags. Look at this. The paper is less. This is less. This is less. This is less. This is less. So what do you conclude? You would conclude that the life cycle assessment, it's more environmental friendly to produce plastic bags. You'd have never thought it, compared to cardboard bags. Look at this, the energy requirements. Look at this. Greenhouse gases, CO2, carbon dioxide, nitrogen dioxide, NO2, dinitrogen tetroxide, N2O4. So these figures may be produced by a manufacturer, but it's common sense. Maybe these are judgmental. They're made by guesswork. These figures aren't accurate. And that's all I want to say about LCAs. You've got to think about it, because it's a trendy subject today. Environmental control, environmental pollution, etc. Looking ahead to the future, like we got a G9, or is it 7 summit coming up for, where globally countries who are eco-friendly are looking into the environmental effects on the manufacture of a product. You know, some of these uses are going up and down. It's like this. We all want white goods in the kitchen, you know, dishwashers, cookers, fridges, etc. We all want cars, more expensive type of cars, with all the whistles and bells and whistles, etc., etc., etc. So there's a lot to think about in this subject, but I'll be speaking about in the next talk will be on recycling. Which of these products can be recycled? And that's all, folks, today.